Today we're going to learn how to visualize and assign electronic and molecular geometry to molecules. So this one has 2 electron domains because you got 2 bonding pairs. So that's the first thing we're going to put on here. And there's 0 lone pairs on this because it's only bonded to these 2 things. Therefore, the electronic and molecular geometries are both going to be linear. We move on to one that has 3 electron pairs on the central atom. So now we're going to have three pairs on the central atom and 0 lone pairs. So we're going to switch out these. The shape of this is trigonal planar. It's just a triangle. All of the atoms connected to the central atom are on the same plane. One of these outside atoms with a lone pair, we see how the electrons from this lone pair push onto the bonds and make the actual molecule look bent. So we keep our electronic geometry of trigonal planar because we still have 3 electron domains around this central atom. So we have the same electronic geometry, different molecular geometry, and that is because we added 1 lone pair to the central atom. So next, structure with 4 different electron pairs around the central atom. We're going to start out with 0 lone pairs, and this one is called tetrahedral. If we're to take off one of the outside atoms and we add 1 lone pair, we see that the lone pair bends these outside and we have a triangular base and it becomes a trigonal pyramidal shape. Now have 1 lone pair, still have 4 different areas of electrons. This still has the potential for 1 more lone pair. So we take this off and we can switch it with 1 more lone pair. And this would be linear. However, these electrons are pressing on it, so we just bend it a little bit. So now the molecular geometry becomes bent. And this is because there are 2 lone pairs. We can move on to ones that have 5 bonding pairs on the central atom. So this one, you can kind of see there's like a triangle formation if you look at down this way, and then you've got a top and a bottom. So there's a triangular base, so you can kind of see a pyramid on the top and a pyramid on the bottom. Then you're able to label this as trigonal bipyramidal. We still have 0 lone pairs, so the electronic and molecular geometries are the same. Let's say we add 1 lone pair, pop this off, add 1 lone pair. Now it becomes seesaw, and we can kind of tell because if you rock it back and forth, it's like a little seesaw. These are in the same plane, then you still have your kind of triangular thing that's in the same plane. So we remove the molecular, never change the electronic, seesaw. Now let's put 2 lone pairs. Take a lone pair from this one since we're not using it anymore. And then we end up with a T-shape. So now this becomes T-shaped. Let's add 1 last lone pair. And you'll see that we kind of have something we've seen before here, which is a linear shape. 5 bonds, 3 lone pairs, so 2 of those have to be actual bonding pairs, and we end up with a linear molecule. We have an atom with 6 different bonding pairs around the central atom. We're going to start with 0, and we'll see that the name of this one is going to be octahedral. A little bit misleading because there are 6 bonding pairs, but that is what it is. Let's add our first lone pair. So we're going to add it just on the bottom right here. And we realize that we form a square pyramid. You can see the square, you got the top right here. So we're adding 1 lone pair, and the structure becomes square pyramidal. Pretty self-explanatory. Then we can pop the top off of this one, and then we have square planar because you just have the base then. So now square planar and 2 lone pairs. These are all of your electronic and molecular geometries that you're going to see.